Welcome back, everybody. In this video, I want to talk about more about graphing linear equations, of course, but I want to talk about a different strategy called the intercepts method. And this one is used quite a bit as well. So first of all, what are intercepts? So we have two intercepts. We have an X intercept and a Y intercept. So the X intercept is the point where the graph touches or crosses the x-axis. To find it, we plug in y equals 0 and solve for x. We get a point that looks like blank, comma, 0. So some number, comma, 0. Now your y-intercept is the other way. It is the point where the graph touches or crosses the y-axis. To find it, we plug in x equals 0 and solve for y. We get a point that looks like 0, comma, some number. Okay, so your x and your y intercepts, what you want to notice is these are where we actually cross the axes. And you're also going to see zeros as one of the values. We actually did have some examples in the last video where we found intercepts. I just didn't call them that, right? So they're just a special kind of point. So let's go ahead and do an example. So this one says to graph x plus 2y equals -4 by finding the intercepts. Now, I'm not going to write a whole bunch of different steps here because it's actually the same exact steps for the plotting point strategy. It's just that we're specifically told which points we have to find. So instead of just plugging in anything we want to, we basically have to plug in the zeros. So the first thing we're going to do is I'm going to find the x-intercept. And I'm going to plug in y equals 0. So I'm going to still make my little table off to the side here, and I'm going to plug in y equals 0 first. So I'm going to go ahead and take my equation here, and I'm going to go ahead and I'm going to replace y with 0, and then I'm going to solve. Now 2 times 0 is just 0. So the nice thing is that you typically get part of your equation that's going to cancel out, and then it's usually pretty easy to solve for the other part. So I'm just going to get x equals -4 here. Okay, so there's my first point, -4, comma, 0. That is my x-intercept. So I'm also going to find the y-intercept. So for the y-intercept, we always plug in x equals 0. Think of these really as definitions. So I'm going to take that equation and replace the x with 0. Now 0 plus 2y, I mean, that 0 can just go away. It's not going to change anything. So I have 2y equals -4. I do the little solving to do here. I'm going to divide both sides by 2. And I have y equals -2. So when I plug in 0, I had y equals -2. So there's my next point. Now, I will say that sometimes when people are talking, they may just say, oh, hey, the x-intercept is -4. Or the y-intercept is -2. So they leave out the 0 because they are assuming that you understand that X and Y intercepts have zeros there. So just as a little side note there, if you're watching videos or reading text or you're typing in answers, sometimes they may just want the actual number, not the full point. So if someone, says, oh, the X intercept is -4, it implies that the 0 is the Y value, even though they're not saying it. So there's a little bit something to watch for. You can still do a third point to check. Now, if you're graphing using intercepts, then you don't want to graph the third point because it's not an intercept, but you're going to use it to visually check that your other points make sense. So maybe here I'm going to pick something easy. I'm going to pick y equals 1. So I have x plus 2 times 1 equals -4. 2 times 1 is 2. Subtract 2 from both sides, and I have x equals -6. So my checkpoint is going to be -6, 1. So this is going to be just for check purposes here. But it's not an intercept, right? It doesn't have a 0, so it's not an intercept. So let's go ahead and draw my picture. So I have 1, 2, 3, 4, -1, -2, -3, -4 there, 5, 6, 1, 2, 3, 4, -1, -2, -3, -4. I'm just putting in a few values here that I need. All right, let's graph this. So I have -4, 0, which is right here. And then I have 0, -2, which is right here. Oops. So there is my graph using the intercepts method. Notice that it is pretty much exactly the same, but except for getting to choose whatever points you want, you have to specifically use the intercepts. So you're specifically plugging in zeros. You can still use a third point to check, but you want to do it more visually. So -6, 1 would be like right here. So that does look like it's going to check out perfectly. So it looks good. Now notice here, right? This is your X intercept. I use INT for short. Notice how it crosses the x-axis. And this here, that is your Y-intercept. I'm just using INT for short. And it crosses the y-axis. Okay, so that is visually what's happening. It's really important to note that because sometimes if you have it, let's say you're given a graph, you actually could just pick out the intercepts with looking, right? So if you had a graph, for instance, let me do a quick example here. So I'm going to do a curve here. Let's mix it up because these definitions still work for curves. So here, let's see, it's 1, 2, this is at 3, and this is at 2 and -2. So I could have a question like this, where I don't even have the equation, I just have a picture, but I could still find the X and Y intercepts because the X intercepts is where you cross the x-axis. So I can see that they're here and here. And then the Y-intercept is where you cross the y-axis. So it's here. So this is my Y-intercept. It's going to be 0, 3. And then my X-intercepts are going to be -2, 0, and 2, 0, right? So the Y values here are still 0 because we're on the axis. And then the X value here is still 0 because, again, you're in the center, you're on the axis. So you can find your intercepts often just from a graph as well. So if you didn't have a whole equation, you could still actually answer a lot of questions like this. All right, let's do one last example. So let's graph y equals 1/2 x using intercepts here. So again, we're going to start. I need to find my x-intercept first. So that means you're going to plug in y equals 0. So I have 0 equals 1/2 x. Now think about how you solve this, right? I can use my fraction technique here. So I can multiply both sides by the denominator, which is 2. That will get that to cancel out. 2 times 0 is 0, and then I just have a 1x left, and 1 times x is just x. So I do have my other value here. So in this case, my y is 0 and my x is 0. Now, when I go to find my y-intercept, you're going to notice something kind of weird happen. I go to plug in x equals 0. Well, 0 times 1/2 is still 0. So I get y equals 0. So I end up getting the same point twice. Now, I didn't do anything wrong here. It just so happens that both the x and the y-intercepts are 0, 0, meaning that we cross at the origin. So we cross both axes in the same place. It's at that perfect center. So if this happens, you will have to break kind of protocol and find another point. So you still need 2 different points, even if it says to use the intercepts. If you've tried both intercepts and they happen to be the same, which doesn't happen often, but it happens sometimes, then you're going to have to go back and just plug in something else because you need a second point to graph. You really do. So I'm just going to go ahead and I'm going to pick, now let's see, here's my equation. So I'm going to pick x equals 2. Because if I plug in 2, then that will cancel with the denominator. So, right? Because 2 over 2 is just 1, right? This cancels out. So I have y is equal to 1 here. So I have 2, 1 as my next point. And if I want to pick a couple extra points here, I'm going to use x equals 4 this time. And again, I'm choosing that because I'm choosing a value because when I'm plugging it in, I want to cancel with my denominator. So here, 4 divided by 2, be careful, is 2. So you're getting 1 times 2, which is 2. Or half of 4 is 2. So I'm just going to try to do a quick little graph right here in the corner for us. So my first point is going to be that origin, right? That's my intercept. You can see it crosses both the x-axis there and the y-axis. So that's why it's the same value. It does cross both axes at the same time. My other point is going to be 2, 1. So even though it says to do intercepts here, I'm still going to have to find another point because I do need 2 different points to graph. And then if I had more room, I could check this and see that 4, 2 looks like it's going to be about right there. So it does work as a checkpoint to still see that extra value. So if you're asked to graph using intercepts, then it's still the same thing we've always been doing, but you have to plug in the zeros. So they're kind of taking that choice away from you and asking you to plug in the zeros. Now, if you're doing plotting points method and you like intercepts, you like plugging in zeros, then go for it. You can always plug in zeros. A lot of times they work out nicely. Sometimes if you have fractions, like if I plug in a 0, here it works out fine, but if I plug in a 0 for the other value, you may still have fractions left over. So you just want to be careful that you're getting some nice answers.